good morning, afternoon, whatever it is. Welcome to Lake City Adventures. I thought I would put out a quick video of an update on the solar system. I'll link the video down below, but you guys may have seen our previous video a few months ago where I did a full walkthrough of our 3 different off-grid solar systems. We're up here in Lake City, Colorado. This is a 12-volt battery bank solar system, and I'm standing here today in our generator shack, which helps power the mine tour. So this solar system actually is powering a business. All this equipment is from Windy Nation. I'll link them down below as well. And I kind of walked you through and gave you a full tour of the system on the last video, so I won't do that again here. But I wanted to give you a couple of updates because we have been having some issues and having to troubleshoot the system quite a bit. So let me kind of just briefly overview the system as a whole, and then I'll tell you what we've done. All right, so way over there on that ground mount pole is our system. And you can see there's 8 panels. Maybe you can't see, but I'll walk over there and show you. There's 8 panels on that ground mount, and then there's an extra 4 panels on the ground. So that's part of the issues that we've been working with, is we've been losing battery and our system's been shutting down, which is a real inconvenience when you're running a business and it's an underground mine tour. You've got a bunch of people back in the tunnel, and if it shuts down, then everybody goes into pitch blackness. So we're trying to work on avoiding that. So there's the panels. I'll show you how they're wired in a second. And they run just along the ground here into this generator shack, come in the wall where we have a twin charge controller setup, Windy Nation TrackMax 40 BT. Needed 2 of these because they're only rated for about 40 amps. These are 12-volt solar panels out there, but I have them wired in series parallel. So it's actually a 24-volt solar array coming in here. And then this is an MPPT charge controllers, which means it can take that voltage that's incoming and then adapt it and modify it down to the appropriate charging voltage for a 12-volt battery bank, which is down here. So we've got 6 100 amp hour batteries, a 600 amp hour battery bank, and then the 12-volt electricity comes out of the battery bank right here through a fuse into the Vertimax 3000 watt power inverter, which converts us from 12 volts to regular AC 115 volt pure sine wave power. This is a little bit of a just temporary setup here. So I have this running to a large gauge extension cord, and then down here to a watt meter. And so essentially this is the main line that goes to the business. This is rated for 30 amps. It's 120, it's not 240. And I used to have this hardwired into the inverter. There's a hardwire spot right on the bottom there. And so the 120 line, 30 amp 120 line, was hardwired directly into the inverter. I created this temporary setup because we kept losing battery power, and I was trying to troubleshoot to see if we weren't producing as much as I thought we were, or if we were using more than I thought we were. So I needed to be able to measure both, and these charge controllers can tell me how much charge was generated in a day, but there wasn't any way to measure how much we're actually using. So I took this 30 amp wire, I wired it to a RV plug because that's really the only plug I could find that was big enough to be able to wire this gauge of wire into. I think this is 8 gauge wire, and then got this adapter. This is only rated for 15 amps, but still 15 amps at 120 volts is 1800 watts, and we should never use more than that in the mine. So it's temporary, it should still be safe. And then this converts the RV plug into a regular 120 plug. And then the reason I did that is so I could plug in this watt meter called kilowatt, and that allows me to be able to track exactly how much we're using. So the anatomy of this thing here is you can click the first button to see your voltage, 118.3. Second button to see how many amps your circuit's pulling. Right now it's 11.9. This is watts, 1,387. Still less than 1,800. This is absolutely everything that we can possibly turn on in the mine turned on, including a sump pump. So we shouldn't ever get higher than this. And then this is hertz, is 60 hertz. And then this last button is what's super helpful. So as long as the power's on, this keeps a running tally of your usage. So if I hit this, you may have heard the fan just kick on for the inverter. That's normal. If I hit this, so far, the system's only been on for 41 minutes, and we've used a total of 0.88 kilowatt hours. So 88 watt hours. Is that right? 880 watt hours. Yeah, 880 watt hours. So essentially, we've used the equivalent electricity of 880 watts for 1 hour, which makes sense because we're using more than 880 watts. We're using 1380, but it's been less than an hour. So the math works out. So this way I can leave this running all day long when the mine's open and get a sense at the end of the day of how many kilowatt hours we're using versus how many kilowatt hours the panels are producing, and then figure out why the batteries are draining. I just wanted to point this out too. This is on the side of this inverter. There's a little display here, and then you can see a switch. It allows you to switch back and forth between watts and volts. So I have it set to watts right now, and this display says we're using, what does that say, 1240, 1270 watts. But you can see if I use the kilowatt meter, it's quite a bit higher, 1380 or so. And I've seen a big discrepancy in those two, so I'm not totally sure which one's accurate, but I suspect this kilowatt is the accurate one, and we're using higher. The inverter display always shows a lower usage than what the kilowatt says. If anybody can explain that to me, please put it in the comments. I don't understand why that is, but regardless, I'm going off of this. And so after I did this system, I determined that I was using more than I thought I was using. And so I reached out to Windy Nation, and their recommendation was that we add extra panels to our setup to be able to provide more charging power, so that we had a little bit more buffer and always went into every day with 100% battery. And then also even during the day, with more panels, then the system's able to keep up better with the usage. So right now, it's a cloudy day outside. So right now we're using 1380 watts. And let me show you, this is half of the system. So one bank is generating 220. There's two of these, so we're generating about probably 440 watts. Not enough to keep up with this usage. But even at this rate, so the net usage is about 1370 minus 440. We're using about 900 watts. If the mine's open for 6 or 7 hours, that's a lot. That's about 900 times 7, 6,300 watt hours, or 6.3 kilowatt hours. That's my entire battery bank. So that's too much. Now that's not normal. Right now, everything is turned on, including a sump pump. So this is way more than our actual normal usage. But when I did the math, we were using about 3.5 to 4 kilowatt hours a day. So this is a 12 volt battery bank, and it's 600 amp hours. So watts is amps times volts. 600 times 12, 7,200 watt hours is 100% to 0% on this battery bank, assuming perfect efficiency. It's not perfect efficiency, so subtract, let's say 20% for efficiency losses, the 7,200, and you decrease that by about 1,400 or so. So the 1,700 is actually more like 6,000, 5,800 watt hours. And then really you don't want to drain your battery bank more than 50% if you could avoid it, to protect the longevity of your batteries. So a 5,800-ish watt hour bank actually gives you, 2,900 watt hours, or 2.9 kilowatt hours. My math showed that our system used about 3.5 or 3.6 kilowatt hours. So assuming there was no charging, if we ran the mine for a full day, we would use more than 50% of the battery bank. Not ideal, but we do have charging. We do have panels charging that help counteract that. And so by adding a few more panels, we counteract that even more and prevent some of those deep losses in the battery bank. So it's a little while later. We've been working on pulling a cable down through a pipe to be able to put a remote meter down in the gift shop of the mine so we can see this. But it came back up here. It hasn't been running that long. We're basically out of battery. We're down to 11.3 volts, or 9%. The fault indicator is not on up here, but it is here. It says fault, and it's an E3, which is low battery voltage, which makes sense at 11.3. It's dropping really, really low. This is about to shut off. And we've only used, so it's been on for an hour and 30 minutes, and we've used less than 2 kilowatt hours, which should be no more than a third of our battery. So why is that so low? I get it, there's a big drain. So right now there's 1,230 watts. So, when there's a big drain like that, it makes the voltage look lower than it actually is. I'm sure if I cut this off, it'd go back up to 12 point something. But I think that's a part of the problem here. When the sun goes away, the voltage coming in goes to nothing, basically, the amperage at least. And there's a big drain on the batteries, and they're not holding their charge very well. So they're basically out of juice an hour and a half in, even though we've only used 2 kilowatt hours. Huh. And that's causing it to shut down, I'm sure. I mean, if it's going to get below, I think the inverter shuts down at 10. But let's see, what does the inverter say? So the inverter says that it is seeing 10.9, 10.8 volts when it's actually 11.3. So the inverter thinks the voltage is lower than the charge controller thinks it is. So yeah, it's going to shut down any second here, I think. Interesting. All right, so we're getting all kinds of beeps and faults and warning. I've got a E3 on this one, which is low battery voltage. I've got an E1 on this one, which is over battery discharge. We've only used 2.06 kilowatt hours. Also, if I can show this before it shuts, this is today. So we have produced 0.4, so 400 watt hours. So we produced 0.4 kilowatt hours, we've used 2 kilowatt hours. So we've only used a net of 1.6 kilowatt hours, and our batteries are dead. And it's a 600 amp hour battery bank, which should have 7.2 kilowatt hours in it. We're only getting 1.4 kilowatt hours. So something is not right. All right, so when we were using 1200 watts, the voltage went all the way down to 10.6. We got the faults and the warnings, and it was just about to shut off. I then unplugged the sump pump, and the wattage went down to about 650 watts, and the voltage improved up to about 12.2, and it was still showing about 20 or 30% charged. And then I just shut the mine off completely, took the load off, and the voltage went all the way up to 13.2 volts, and it says 99%. So it's like it can't handle a load on it. And as soon as there's a decent load on it, the batteries just drain all the way down to a voltage that's low enough to kill the inverter. But then as soon as you take the load off, the voltage goes all the way back up to 100%. Does that mean my batteries are dead? Is that what I'm dealing with here? Now, if I tried to turn off the solar system and let it sit without any charging for a day, and it held its voltage. So it's not draining spontaneously, but it's like once there's a load on it, it won't hold voltage and it just goes down to zero. So what I'm going to try to do now is, so it's 100%, 13.5 volts. I'm going to turn the mine back on. Okay, this watt meter should fire up. It's using 719 watts, and it's holding at 13.2 volts. Now I'm going to let it sit here for a while and we're going to see what happens. All right, so these are wired as two separate arrays. So I've got the red and black positive and negative coming in to this set and then coming into that set. They're separate. And then I've got each pair of panels, like for example, here's the top pair of panels, and it's wired in series with the positive of the left one and the negative of the right one. The bottom pair is the same, and then the pair on the ground is the same. And then coming up here, I've got branch connectors so that this is the main line coming in, and then it branches there, and this positive line goes down to that pair of cables, and then the other side branches again. So these positive lines each go to the top pair and the bottom pair. And same thing on the negative side. So there's one negative cable coming in from each pair. It branches there, and then it branches with the negative coming in from the pair on the ground into one negative cable going back to the charge controller. Same setup on this side. You know, the top two are in series, the bottom two are in series, the two on the ground are in series. So there's 3 banks, and then it's wired in parallel here where one splits into 3. So is that correct? I question everything now. So it's only been on for a little while. It's used 0.1 kilowatt hours. It's been on for 9 minutes, and the voltage is down to 11.5, and it's about to shut down again. So something's not right. That's not possible. It's like as soon as there's a sustained load on it for a few minutes, the batteries just plummet in voltage. To me, that tells me these batteries are no good, which is such a bummer. is there's 6 batteries in here that are over $200 each. It'd be $1,200 in batteries. Ugh. So again, they were down to 11.5 and I was getting an E3 low voltage warning again. They just turned off the mine and instantly batteries go back up to 13.2 volts and show 100%. So, I mean, and it was only drawing 600 or 700 watts. So what does that mean? Well, hello again. I'm back up in the generator shack. You can probably tell, outfit changed. This is a different day. Still working on troubleshooting this solar system. You could probably hear it in the background, but the generator's running. So the mine's going off of generator right now. I did some tests yesterday, charged these batteries up to 100%, went down to the mine, turned on the water pump, turned on a couple different things to be pulling about 1,000 watts. And the battery bank went from 100% to virtually zero. So it was 12.9 volts down to 11.5 volts in about an hour. A little over 1 hour per 1,000 watts, or about 1 kilowatt hour. This is a 600 amp hour 12 volt battery bank. It should have 7.2 kilowatt hours, 7,200 watt hours. It has 7.2, but it died after 1. So something is not right with this battery bank. Windy Nation asked me to rewire it just a little bit. I have the 6 batteries wired in what they call a perfectly balanced configuration. And they had me originally install the charging line on the same post as the discharging line. So the inverter was connected to the same positive as the charge controllers were. So they had me switch that a little bit to kind of get the current flowing differently in the battery bank. I did that before I ran that test, and that test was still dismal. So something's not right. It's my hope that maybe only one of these batteries has failed, but because they're in a battery bank all wired together, you can't tell that. And they're not all failing. Because these batteries are over $200 each. There's 6 of them. This is $1,200 in batteries. Do not want to be replacing $1,200 in batteries. So today we're going to do a test. And we're going to come up here. We are up here. We are going to disconnect all these batteries and then reconnect them back up one at a time so that there's no battery bank. And we're just testing each battery just testing each battery individually. And we're going to put a load on it. Let me show you. All right, so here's the bank as it stands now. It's a little dusty. I'll fix that today while I'm working on this. So you can see 6 batteries. And what I mean by perfectly balanced charging is you don't want to do, these batteries are wired in parallel. So all the negatives are together, all the positives are together to keep them 12 volts. You don't want to just kind of wire all 6 together in a line and then put your charging on the first one and your discharging on the last one, because then the first battery will see a lot higher voltage than the last battery, and over time it causes wear. So I don't pretend to fully understand this, but I wired it according to the diagram that they sent me, which allows you to have the electricity kind of balanced and equal voltage in all 6 batteries. And so this right here is the negative post where the 2 charging cables are coming in from the charge controller, and there's the equivalent positive post back there. I used to have the inverter connected here too, but I've disconnected it and put it on this post over here. And then the positive is on the back there. So this is supposed to be, still balanced. So the charging comes in negative there, positive there, and then inverter negative there, positive there. What we're gonna do now is we're gonna disconnect all these batteries completely, pull all 6 of them out of here, and then hook up one battery at a time. They're all fully charged as of right now. They were all just on float charge. We're gonna hook up one battery at a time, and then we're gonna run our inverter here. And I brought this little Vornado space heater, pulls about 700 watts. So we're gonna hook it up, blow it out the window so it doesn't roast me, and just put a 700 watt load on each battery individually for a period of time and see how long they last, and kind of document all the numbers and how many minutes it lasts. We'll use the watt meter so we can know exactly how many kilowatt hours were used and how fast the battery dropped, and then see if they're all the same, or if there's one battery here that's a bad apple and I just need to replace one battery, which would be amazing. So let's get started. And what we're gonna do first, so I went out there to the panels, to the arrays out there, and I disconnected, it's not gonna charge. It's not gonna focus. I disconnected the charging cables coming in, so there is no charging. You can see on the little display, it's got that little sliver moon next to the panels. So there's no charging coming in because I want no current running through this system when I'm working on it. So the charging is disconnected, and then this is still plugged in. I'll reach back here and turn this off just to be safe, but this is not plugged into anything. And the inverter is obviously turned off. I'm gonna disconnect the remote switch so nobody can fire it up down at the mine. So it is off, it is disconnected, panels are disconnected. So now we can start working on disconnecting all the batteries, getting them out of the way, and getting it down to this one battery. So let's see how it goes. So that wasn't too bad. We've got them all disconnected. And here's all the battery cables up here. These are 1/0 cables, I think. Are they 1/0 or 2/0? I think they're 1/0 cables. Because this is a 12-volt battery bank. This is a 3,000 watt inverter with a peak of 6,000. So if it's 12 volts and 3,000 watts, 3,000 divided by 12 is 250 amps. So these things need to be able to carry 250 amps, as do these, which is why they're the big hefty guys. There's quite a bit of cost in these battery cables. All right, so we got them all disconnected. Now we're gonna take them all down, and then we're gonna put one battery at a time in the center there. All right, so we've got our first battery connected, just as one battery. So I've got two charge controllers, so they're both connected to the negative as well as the inverter. Both charge controller positives to the positive as well as the inverter. And my displays look good. 13.5 volts, 100% charge, 13.5 volts, no charge coming in. So we're going to turn on the power to the inverter. And then this is running through this kilowatt meter right here. And I'm gonna get my heater set up and we'll turn that on and see what happens. All right, so we have the heater plugged in. This is a Vornado. It's got 3 settings on it, low, medium, and high. I have it on low, and I tested it at home. It's about 700 watts. Medium's 1,000, high is 1,300 watts. So this should be a 100 amp hour battery. So at 12 volts, 100 times 12 is 1,200 watt hours. This thing, if it's pulling 700 watts, you know, should be able to run for not quite 2 hours with a 1,200 watt hour battery. That's what that means. It can run 1,200 watts for 1 hour. It can run 600 watts for 2 hours, etc. This is 700 watts, so a little bit more than half the battery. So if it's working as it should be, I should be able to run this thing for an hour and only take 700 out of the 1,200 watt hours available in this battery. So I should take it down to a little bit less than 50% over an hour. If it crashes in 10 minutes, then we know there's a problem with the battery. All right, connections are good. I just double checked them. They're all tight. These 2 lines running down here are just for a temperature sensor, and it's firmly stuck to the battery. I didn't want to mess with that, so I just left that alone, but that's not part of the deal. Let's just get it out of the way. And let's turn the inverter on. Switch over here, hopefully nothing blows up in my face. Okay, inverter on. This shows that we are getting, can you see this? We're getting 118.5 volts, very reasonable. And right now, no watts, because the heater's turned off. And when I turned that on, it dropped the voltage by 0.1 just to power the inverter, but it still says 100%. So we're starting at 13.4. And let's turn this guy on. Huh, it still says no watts. Why is it not turning on? Weird. Oh, I know why. This thing has a tilt sensor on it. There it goes. So it won't run if it's not flat on the ground. It's a safety issue. So I had to put it flat on the ground. So now it's running 712 watts, 709 watts. Pretty constant draw. So these guys, oh boy, it instantly dropped to 12.2. Now it will drop quite a bit when there's a load on it. That's normal. The question is it going to keep plummeting, or did it drop to 12.2 just because there's a load on it and now it's going to take a while to drop down from there? So let's let this run and we'll see what happens. Test is running. It's been 5 minutes. It's dropped to 12.0 volts or 12.1 depending on the meter. 12.1 right now. I did go ahead and put a duct tape label on every battery. 1, This one is 6, 5, 4. They all have labels on it. And that's how I keep track of my notes, so I don't lose track of which battery is which. Let's see. It's kind of holding. I mean, it's already dropped 0.1 to 0.2 volts, maybe 11.9 already. I don't know. We'll see how it goes here in the next few minutes. It's 1:56. It's been 6 minutes. They're plummeting. 10.4 volts, 10.2 volts. And it's basically going to zero. Oh, what the heck? Now it kicked back up to 12.5, 12.6 with a fault. Up here still says, oh, now it just updated, 12.6. Well, that was weird. It dropped down to, okay, did the inverter? Yeah. So the inverter kicked itself off. The inverter's off, and I'm getting a 2, 3, 4 blinker. 1, 2, 3, 4 blinker alert. So that's why the voltage went back up. You saw it drop down to like 9.6, and then the inverter kicked itself off for low voltage, and you can see the watt meter's now dead. But then as soon as the inverter kicked itself off, the battery voltage went right back up to 12.8, which is nearly fully charged. This says 80%, but I think that's pretty close to 100%. So the battery's not actually drained, it just couldn't handle running a load on it. All right, so that was our first battery, and it failed and shut the inverter off within 7 minutes. 7 minutes at 700 watts is what, 4,900 watts, so 4.9 amp hours. So it shut this thing down at 4.9 amp hours, even though it is rated at 100 amp hours. So that's not great. Question is this just this one battery? Did I get lucky and find the bad one first? Or are they all the same? Is the whole bank not performing? I guess we'll find out. You can see it's been just sitting here off load for a while, and it still reached 12.9 volts, 86%, 12.9 volts. So this battery is still pretty much fully charged. It's not dead. It just can't handle a load on it. Whenever it has a load on it, the voltage just plummets within a few minutes. So let's see. Let's try number 2. All right, battery 2 installed the same way. 13.4 volts, pretty similar to the first one. And then I unplugged my heater just to be safe, so I'm gonna plug it back in. All right, so battery 2 starting at 13.4 volts. Inverter on. Dropped to 13.3 or so, it's still 13.4. And then heater on. It kicked on. 725 watts, 722, pretty similar, down to about 12.2, 12.3. Man, I feel like all 6 of these are gonna be the same. Let's see how it goes. All right, it's been about 5 minutes and we're still 12.2. It fluctuates between 12.1, 12.2, and 12.3, but is that a good sign? It's not dropping as fast as the other one. Let's see how it continues to go. It's 5 minutes in. All right, I got so into what I was doing, I forgot to film. So battery 2 ended up lasting 18 minutes. And I shut it down myself just because it was slowly dropping and it was approaching 11 volts. So there was a big difference between battery 1 and battery 2. That's a good thing. It makes me hope maybe there's only one dead battery. So this is battery 3. I just hooked up battery 3. All right, testing continues. We're gonna try this one because this tested the best on the other load tester. This is battery 5. So battery 1 failed in 5 minutes. Battery 2 went 18 minutes down to 11 volts. Battery 3 we just ran for 29 minutes and only got it down to 11.5 volts. So 1 was dead, 2 was not great, and 3 was awesome. So now we've got battery 5 plugged in here, starting at 13.3 volts. Let's turn inverter on. Inverter's on, 120 volts. Heater's on, ramping up, 700 and something. And we're gonna start off at the same place, about 12.2 to 12.3. And let's see how long you can run it. Battery 5 testing is underway. While it's testing, I wanted to show you something else that I did. So these are the charge controllers right here. There's 2 of them, as I've talked about before. This is a remote monitor that allows you to put a monitor, you know, in a different setup. You might have this outside, you might have this inside, and then you can run this phone cable. And it says it's rated for a 5-meter cable. Well, we tested that theory. So this is the cable underneath here that's going to that remote meter. On this charge controller, here's the cable. I'm running it outside, and let me show you where it goes. Sorry for the generator noise. Cable's coming out right here. It runs down here behind this debris pile here. Runs across these tires. Runs past the solar panel array. Spoiler alert, this is a 300-foot cable. RJ12 6-wire. It is rated for outdoor, for burial. Right now it's just sitting on the ground, which isn't ideal. We need to bury it and get it protected from the UV rays. But it comes all the way here across the hill. By the way, we're walking above the mine right now, so the mine's underneath us. Runs all the way down the hill. And if you see where that antenna is right there, sorry, I try not to change the focus, but right there. And there's a pipe right next to it. Let me go show you. So here's the pipe. This is the entrance to the mine down there. And then this is a pipe that goes down 26 feet through solid rock down into the gift shop. So here's that wire right here. We had a heck of a time fishing it down this pipe, but we did. So it runs 26 feet underground into the gift shop. And then it runs about another 10 feet over to our counter where the cash register is. And right there, I have the remote monitor set up and it works great. Even though the manual says 5-meter cable is what it's rated for, it's running 300 feet. And it's really nice because it allows the people who are working in the mine to be able to keep an eye on the battery voltage from down there without having to make the trek all the way up here to the shack where the panels and the batteries are. So let's go back in and see how that test is going. All right, guys, well, battery 5 was not good either. Failed after 13 minutes. So far, I think battery 1 failed after 5 minutes. Battery 5 failed after 13 minutes. Battery 2 failed after about 18 minutes. And then the other battery we tested lasted almost 30 minutes. All right, just fired up the last battery, battery 4. I did them a little bit out of order. Holding a 12.2. The second to last battery I did was junk. It died within 6 minutes. So, dang it. 2 dead batteries, 1 not very good battery, 1 average battery, and 1 very good battery for whatever reason. Why they're uneven, I don't know. We have finished testing all 6 batteries. So final conclusions, 2 of the batteries failed within about 6 minutes. I think those are pretty much dead. And then the next 3 batteries, 1 was 13 minutes, 1 was 17 minutes, and 1 was 21 minutes. So those seem like they're kind of partially okay, partially damaged. And then 1 battery chugged all the way for 29 minutes and still had 11.5 volts. So that 1 battery seems good. But unfortunately, it seems like of my 6 batteries, 2 are dead, and maybe 5 of them need to be replaced. I'm not sure. So reaching out to Windy Nation, and I'll report back and let you guys know what they come up with and what they say and what they think happened. So we got it all hooked back up. I took out the 2 batteries that are the ones that failed within 6 minutes. And so these are, you know, the really good one and the other 3 that were kind of average. They're wired again in the perfectly balanced configuration, so it's not just one side to the other, but it's even voltage across. I'm back to just having the inverter and the charging cables connecting to the same cable. And we're at 12.8, which is high, you know, 82%. Batteries are still in good shape. And I think what I'm going to do, I thought about just hooking up the panels, but before I put a charge back on them, I think what I'm going to do is set this heater back up, put it on high, and see how it does with the 4 full 400 amp hour battery bank connected and the 1300 watt heater. See if it can handle it, see how quickly the voltage drops, see what that looks like. So I'm going to test that next. So we started at 12.8 volts. I turned the heater on, 730 watts. This is still on low, and it's down to 12.4, 12.3. But now, you know, instead of a 100 amp hour bank, it's a 400 amp hour bank, so it should last much longer. The question is how long? What happens if I put it on high? Wattage goes up to 1334. And look at that, we already dropped down to, we already get a fault for low voltage. Huh. Interesting. All right, I'm gonna go back to low. And so it should settle out at about 12.3 or so. It looks like it's already 12.1, 12.2. So that's with no charging, right? There's no solar. I could go plug in the solar panels and get it back up to 13 volts and it would show 100% battery. But I'm curious to see what it looks like without any charging and just the load on just the batteries. So it went from 12.8 to now it's hanging out about 12.2, even though we're back down to the low setting at 740 watts. So let me let this run for a while. Let's see what happens here. So this test is not going great. Even though these are the 4 best batteries we have, the 2 dead ones are down there. We started with the inverter off at 12.8. When we applied our load, it went to 12.2. It's been 10 minutes and it's already down to 11.5. So I don't think this is gonna make it even 15, 20 minutes. My guess is 15 because it usually drops a little bit quicker at this point. So a 400 amp hour bank, which times 12 should be a 4,800 watt hour, is only able to run a 670 to 700 watt heater for 15 minutes. That does not seem right. So we'll see. I'll keep this going, and once it hits 11.0, I'll shut it off and then document the time. All right, guys. So I just wanted to give some follow up to this testing. It's a couple of days later, maybe 2 days later. And I mentioned that I got all this equipment from Windy Nation, including these batteries and charge controllers. And I had been so impressed with Windy Nation throughout the years. I've installed several systems with them. And so I immediately emailed them and sent them the results of all these tests. And they replied quickly. We went back and forth, clarifying different things, multiple emails back and forth, and kind of finally came to the consensus that, something happened to these batteries. I'm not sure what it was. We've added more solar panels. There may have been times when they got too discharged. I'm not sure. If it did, it didn't seem like it was a whole bunch. We didn't see any other obvious problems with the setup. But even though these batteries are way out of warranty, this system is 2 years, going on 3 years old. So there's no longer a warranty, but Windy Nation was gracious enough to go ahead and replace 2 of the batteries at no charge. Those 2 that really failed immediately. So they're sending me 2 new batteries. And then they recommended a device that I got on Amazon called the Battery Minder, which is a desulfator, essentially to remove some of the sulfur buildup on the battery terminals. Again, I'm not a chemist. I don't fully understand this, but I pulled up this device on Amazon and this is exactly what it's supposed to do. So it applies kind of this high frequency, but also higher voltage to try to equalize the battery and desulfate it and get it functional again. So we're really hopeful that at least the 3 batteries that were kind of partially wrecked, I can restore those to a much better condition with this device. The 2 that were totally dead, I'll try them on those 2, but I think those might be totally dead. But hopefully with 2 new batteries, the 1 battery that was fine, and then we can recondition the 3 other batteries, we'll get back up and running again. So I'll keep you guys posted. Thanks again to Windy Nation for helping me troubleshoot and working with me and shipping me the new batteries. And I'll make another video once I get that new device in and we're able to desulfate those batteries and hook them back up and do another load test and see if we made any difference, any improvements. I sure hope so. So thanks, guys. Thanks for watching. I kind of shot this video as I was doing it, and I didn't know how it was going to turn out. So hopefully it's mildly interesting to those of you that are kind of tech-minded about how we troubleshot this. And please put in the comments down below what you think. What did I do wrong with my troubleshooting? What would you suggest? And do you have any suggestions as to what happened to these batteries and why they can't hold voltage when there's a load applied to them? So thanks for watching, guys. Stay tuned for part 2 of the video. It'll probably be a few days or so until I get that device shipped, or at least in my hands. So the next video should be a few days from now, and I'll show you how it went, and we'll go from there. Thanks.